Now that we've talked about addition and subtraction, let's talk about multiplication and matrices. There are actually two different types of multiplication when it comes to matrices: scalar multiplication and matrix multiplication. For now, I'm going to deal with scalar multiplication. So the first question is, what exactly is a scalar? For our purposes, a scalar is just going to be a real number. And there may be reasons to make this a complex number sometimes or something like that, but for us, a scalar is just going to be another word for a number. And if R is a scalar and A is a matrix, then we call RA a scalar multiple of A. And so this is the idea of scalar multiplication. I'm going to be multiplying a number and a matrix. And the way we do this is RA is equal to R times A sub ij. So essentially what this means is we're going to multiply every single entry of the matrix by this number. So let's look at an example. Here I have a matrix A with 3 rows and 2 columns, and I want to find negative 2A. So this means multiply everything in this matrix by negative 2. So I'm just going to multiply the entire matrix by negative 2. And from there we can start simplifying. I get 0, negative 14 in the first row, 12, 14 in the second row, and 6, 2 in the third row. So now I have the scalar multiple. Now that we have this idea of scalar multiplication, let's look at some of the properties of scalar multiplication. We're going to let A and B be matrices of the same size, and we're going to let R and S be scalars. So there are 3 properties that I'm going to look at. The first is a distributive property. R times A plus B is equal to RA plus RB. I can distribute a scalar over a sum of matrices. The second is another form of the distributive property. R plus S times A is equal to RA plus SA. So the first one says I can distribute a scalar over a sum of matrices. The second one says I can distribute a matrix over a sum of scalars. And the third one is going to be an associativity property. R times SA is equal to RS times A. So if I'm multiplying a matrix by multiple scalars, I can either multiply all the scalars and then multiply by the matrix, or I can multiply the matrix by the scalars one by one. And so I'm going to go ahead and prove the first one of these, this first distributive property, and I highly encourage you to work out the other 2. This is what I want to prove. R times A plus B is equal to RA plus RB. So I'm going to consider 2 matrices. I'm going to let AB be m by n matrices, so they need to be the same size, and let R be a scalar. I'm then going to consider the entry in row I and column J of A plus B, which we know is given by A sub ij plus B sub ij. Since A sub ij and B sub ij are just real numbers, we know the distributive property holds for those. So I have R times Aij plus Bij is equal to R times Aij plus R times Bij. And by definition of scalar multiplication, this is the entry in row I and column J of RA plus RB. So since I proved that these 2 things were equal for row I and column J, which is an arbitrary entry in this matrix, it has to be true for all of the entries. So it has to hold true that R times A plus B is equal to RA plus RB.